Hello and welcome to an overview of VisualVM. VisualVM is a dynamic analysis tool for analyzing Java programs. VM comes from virtual machine. It looks at the Java virtual machine and gets data on the programs that are running on your computer. I'm Ben, and my partner George will be explaining some parts later in the video. So you can download it on their website, and for Windows, open up the download, extract the file. Inside the bin, you'll find an executable. Executable will start an application. George will explain the basics, and then I'll get into the threads and the other parts.
All you have to do to analyze a program in VisualVM is open the program while VisualVM is open. The program you wish to analyze must be written in Java. Let's do that now. The program I'll demonstrate is called Processing, an open source IDE for visual design. The program that you opened will appear automatically on the left side in the Applications tab. Once you see it, simply double-click on it. The Monitor section monitors the CPU, heap, classes, and thread of the program all in real time. The heap section shows the total heap size and how much is currently being used. A heap is storage for your Java objects via the Java virtual machine. As you can see, the heap goes down immediately when pressed. A garbage collection is the automatic process of taking unused allocated memory, which was previously allocated, which you're doing manually by pressing the button. The heap dump button performs a snapshot of the program at that specific time. You can even save the file as a HPROF file for later to compare. Also note, when you close the program while VisualVM is running, all stats will be stopped, almost like a heap dump. If you open the program again, it'll open the same program name, but with a different ID number. Now I'll have my teammate explain threads, sampler, and profiler sections.
The next tab to discuss is the Threads tab. The Threads tab shows all the threads that are running on the analyzed program. It shows them whether or not they are running, sleeping, wait, park, or monitor mode. And you can see in real time how they change. So if we look at the Event Queue tab, thread here, you can see how many milliseconds it's been running. And if we open up processing and we make an event and we hit save, then we should see that there is a change in the event queue, as we do here with the sleeping section. Change it back, we'll see another change. So this way, a lot of Java programs are divided. When you write the Java program, you create your own threads. You create a graphics thread, you might create a thread for the actual processing, and this way you can analyze your threads that you wrote and see how active they are. So if they're always running, if they're in sleeping too much, then you can look at that here. Thread dump will give data on each thread, and you can save that to a file and load it as well. You can zoom in or zoom out. You can even show all threads and finished threads here. Alright, moving on to the Sampler tab. We can create a sample of the CPU usage, the memory usage, and also stop it. We can also change the settings. First, I'll start with the CPU. This shows the threads and goes into function by function use of the CPU usage. So this shows that the run function has been going for 10,000 milliseconds and using a lot of the CPU time, a lot of the total time. The thread CPU time shows each thread and shows how much time it's actually on the CPU compared to the time that the whole program is on the CPU. So whenever this program is on the CPU, 57% of the time it is the event queue, and only 0.1% of the time is the timer queue on the CPU out of the time this program is using the CPU. Same goes for memory. You can figure out which sections of your code are using the most memory. So there's an int array somewhere that is using 20% of the memory that the whole program is using. You can pause it and refresh, So this way you can see at one moment or update to the latest moment. You can also take a snapshot here, and it'll give you a freeze frame that you can save and load to compare it against other systems. So you might be able to save this, send it to your coworker, and they can analyze how the same program runs on their machine and how much memory usage or CPU usage they're using. Finally, let's look at the Profiler tab. Profiler tab is very similar to the Sampler tab. It will analyze your program and give you data on how long each function call takes. So this function call here, action performed, is taking 1.35 milliseconds total time. You can pause it, refresh, change the view, and snapshot similar to the other tabs. You can do this for memory and for the database calls as well. Similar to the sampler, it has a settings option. When the sampler and the profiler aren't running, you can change the settings of what classes they look at. So in here, I could add the classes that I want to look at, that I wrote, or that I think are using the most time on the CPU or using the most memory, to figure out where the problems are in my code. So I could add in the classes that I've written here, classes I want to look for memory leaks, look for loops, and I can also look for particular texts in SQL queries. Overall, this tab and the sampler tab are great for finding where your code is spending the most time, maybe where you need to work on it, maybe you need to improve the speed of a certain function call. You can see how much time each function is taking. Overall, VisualVM is a wonderful dynamic analysis tool for looking at your Java programs, figuring out their CPU usage, their heap space, classes, threads. Maybe if you have a memory leak, your garbage collection will be running frequently and taking some CPU usage away from the rest of your program. There are some extra packages you can install that are supported by VisualVM as well as by third-party members, and they have a wonderful forums for questions on their website. They have a live chat and bug reporting section on GitHub. This is an open source program, which is nice if you want to work on it yourself, help support the environment, improve the program. You can always support it on GitHub. Thanks for watching. I hope you learned how to use VisualVM in this video. And thank you, George, for his section earlier on.